Okay, today we're going to talk about percentage composition and empirical formulae. 2 bits using moles. So, first thing we need to think about is chemical reactions a bit. And what happens? Well, when a chemical reacts, we must still have everything we had at the end. We mentioned that a bit last video with our conservation of mass. We can't get rid of that, it must still be around somewhere. So, say we had 14 kilos of nitrogen in our Haber cycle and 3 kilos of hydrogen. They're going to react to make our ammonia. Well, how much ammonia can be made? Assuming this is the right reaction ratio, which it is, we're going to make 17 kilograms of ammonia because we can't have created or destroyed mass, so we can only add those together, assuming these are the right quantities, and they are. The other way of thinking about it, go the other way. We had 34 grams of ammonia, which we know contains 28 grams of nitrogen. It must contain 6 grams of hydrogen. Just the way it must be, because all we've got is nitrogen and hydrogen. We know how much nitrogen we've got. Left over must be hydrogen. So conservation of mass makes that sort of calculation quite straightforward. Now, the molecular formula and the empirical formula are 2 similar, related, but slightly different things. For instance, you might have an alkane, or alkene. Alkenes are easier to think about for this. C6H12. CnH2n. That's its molecular formula. But actually its empirical formula is the simplest form of that, and we can cancel that down to CH2. That just tells us the ratio. For every carbon, there's 2 hydrogens. That is the empirical formula. Simplest possible option. That's what the empirical formula is. So, here's what we do. We can work these out from some known quantities. As an example, say we know that 2.45 grams of sulfuric acid, H2SO4, contains 0.05 grams of hydrogen. It's got 0.8 grams of sulfur, and it's got 1.6 grams of oxygen. So far, so good. Whole set of numbers. If we were missing one, we could work it out from conservation of mass, but we've got all 3 of the things we need there. Part 1. Mass of each element. So we've got hydrogen, we've got sulfur, we've got oxygen, which is 0.05, 0.8, 1.6. It's just repeating that. I'm just laying this out nice and step by step. Step 2. Relative atomic mass of each element. So that's 1, 32, and 16. Step 3. Work out our moles. Remember, moles is mass divided by mR, so 0.05, 0.025, and 0.1. Step 4, which is smallest. Now, you should always get ones that work out nicely at this point. Sulfur is our smallest, 0.025. And then stage 5 is to divide by the smallest. So that gives us 1, 2 and 4, which means that our empirical formula is H2SO4. Could be a 1 in there, but we tend to drop the ones because chemists are lazy. That is our empirical formula. Nice and straightforward. In the case of sulfuric acid, it is the molecular formula, but it could just as well not be. It could have needed to be a multiple. So, just to recap, step 1, find out the mass of each element. Use conservation of mass if you need to. Step 2, find out the relative atomic mass from the periodic table. Step 3, moles is mass divided by atomic mass. 1 divided by 2 gives you the moles. Step 4, identify the one that's smallest. Step 5, divide through by that smallest one to give you your empirical numbers. And then step 6 would be to write out the empirical formula. If you don't quite get perfect numbers here, double check everything first. In an exam, you should get quite nice numbers, so don't panic, but double check everything before going on. That's working out an empirical formula. So that was the first thing. The second thing in this section is thinking about how much water there is in a crystal. Now we did this as a practical. We had some problems with the calculations. What we did was we had our heat. We had our basin with our lovely blue crystals in. And we heated that until we ended up with our crucible with white, or well, I'm going to have to draw black crystals in. And what we did was we drove off the water. We measured the mass before and after, and we measured the mass of the crucible. So we had overall a mass before and a mass after. The difference between those before minus after is the number of is the mass, I should say, of water, from which we could work out the moles. The mass after was the mass of our copper sulfate. So that tells us how much copper sulfate we had. From those two, we could work out how much of each thing there was. So imagine we had 25 grams before, and we had 16 grams after. That would mean we had 9 grams of water. So let's see if we can work this out. Copper sulfate. Moles is mass divided by mR. So let's start by working out the mR. mR of copper sulfate is going to be mass of copper, which is 64 plus sulfur, which is 32, plus 4 oxygens, 16. So that is 64 96 plus 64, which is going to be 160 grams per mole. No, just grams, not grams. Moles. 160 moles copper sulfate. Grams per mole. So that's our relative mass. If we take our relative mass, convert that into moles. So moles, copper sulfate is the mass that we've got divided by our formula mass. That's going to be 0.1 moles, because this is a tenth. So we have 0.1 moles of copper sulfate. What about our water? Well, the MR of water, relative mass, is going to be 16 plus 2, 18. Moles is mass divided by MR, 0.5 moles. So if we look at this, for every 0.1 we have 0.5, so for every 1 mole we're going to have 5 moles, just times by 10. So copper sulfate, 1 mole, put a dot for water of crystallization, and this is water that's stored in this crystal lattice, is going to give us 5 waters. So that is the full formula for our copper sulfate. Last thing, well, two last things. First of all, percentage mass. Percentage mass is total mass of that element divided by total mass of the compound. Total formula masses would be one way of looking at that. So, for instance, C2H6, nice straightforward ethane. The percentage of the carbon, got 2 carbons, say total 24, 2 times 12, plus 6 hydrogens. So that's the total mass of the element, 2 times 12, plus the total mass of the compound, 30. 24 out of 30, times by 100 to make it a percent, gives us 80% carbon. So we're expecting we should get 20% hydrogen. Let's have a look. Percentage of hydrogen, 6 out of 30, which is indeed 20%. So percentage mass, quite straightforward. Amount of mass you have divided by total mass. And then finally for this video, empirical formula. So, if you've got, again, sulfuric acid, and we know that it's got 2.04% hydrogen, and this is a realistic thing you might get in a research lab. Someone would do an elemental analysis and tell you these things. And you've got 32.65% of our sulfur and 65.31% of our oxygen. by mass. Step 1. We need to work out our mass. These percentages, let's make it easy on ourselves if we can. Mass in 100 grams. So that means we've got 2.04 of hydrogen, it's grams, 32.65 grams sulfur, and we've got 65.31 grams of oxygen. Then it's just the same as before. Relative masses: 1, 32, 16. Convert to moles: 2.04, 1.02, 4.08. Lowest moles, as you'd expect from the previous time, sulfur, and finally divide. That gives us 1, 2, and 4. H2SO4. So again, H2SO4 straight off by working through from percentage compositions this time. That's all we need about empirical formula.